To solve an equation using the quadratic formula, we first write the equation in standard form. Next, we identify the values of a, b, and c from the equation. And then finally, we substitute those values into the formula and simplify our solutions. Let's do some examples. In problem 1, we have 4x squared plus 3x minus 2 equals 0. This equation is already in standard form, so we can see that the value of a is 4, the value of b is 3, and the value of c is negative 2. Substituting these values into the quadratic formula, which is shown in the yellow box on the slide, we have x equals negative 3 plus or minus the square root of 3 squared minus 4 times 4 times negative 2, all over 2 times 4. Now let's simplify this expression. We have x equals negative 3 plus or minus the square root of 9 minus 4 times 4 times negative 2 is negative 32. And in the denominator, 2 times 4 is 8. Note that 9 minus negative 32 would be the same thing as 9 plus 32. So we have negative 3 plus or minus the square root of 41 all over 8. And so we can write those two solutions to the quadratic equation in our solution set. Let's move to our second example. X squared minus 6x plus 8 equals 0. In this case, a equals 1, b equals negative 6, and c equals 8. Substituting into the quadratic formula, we obtain x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 8 all over 2 times 1. Simplifying, the opposite of negative 6 is 6. So we have 6 plus or minus the square root of 36 minus 32 all over 2 times 1, which is just 2. This is 6 plus or minus the square root of 4 over 2. And since the square root of 4 is 2, we have 6 plus or minus 2 divided by 2 as our solutions. To write these solutions in simplest form, let's separate them and consider each one individually. First, 6 plus 2 divided by 2 would be 8 divided by 2, or 4. And then 6 minus 2 divided by 2 would be 4 divided by 2, which is 2. So the two solutions of this quadratic equation are 2 and 4. Moving to example 3, x squared minus 7 equals 2 times the quantity x plus 1. Before we can apply the quadratic formula, we need to write this equation in standard form. So let's use the distributive property to multiply on the right-hand side. And then let's subtract 2x from both sides. And then let's also subtract 2 from both sides. So we have x squared minus 2x minus 9 equals 0. Since the equation is in standard form, we can see that a is 1, b is negative 2, and c is negative 9. And we can substitute these values into the quadratic formula. Simplifying, we have 2 plus or minus the square root of 4 minus negative 36 all over 2, or 2 plus or minus the square root of 40 over 2. Note that the square root of 40 can be simplified since there's a perfect square factor, which is 4, so we can bring that square root of 4 out of the radical and write the square root of 40 as 2 square root of 10. And now, since all terms in this expression are divisible by 2, we can factor out that 2 from the numerator and simplify with the 2 in the denominator. So our two solutions are 1 plus the square root of 10 and 1 minus the square root of 10. Finally, let's look at example 4. Note that once again, this equation is not written in standard form, so we will write it in standard form before we can apply the quadratic formula. Multiplying out the binomials on the left-hand side of the equation leads to x squared plus 4x plus 5x plus 20. And then we can add x squared to both sides. Combine 4x and 5x, and then we can subtract 13 from both sides to obtain 2x squared plus 9x plus 7 equals 0. Now substituting into the quadratic formula, we have x equals -9 plus or minus the square root of 9 squared minus 4 times 2 times 7 all over 2 times 2. Or -9 plus or minus the square root of 81 minus 56 all over 4. Simplifying further, since 81 minus 56 is 25, we can write our answers as -9 plus or minus 5 over 4. To identify our two solutions in simplest form, once again we separate them and we write -9 plus 5 divided by 4, which is -1, and then -9 minus 5 divided by 4, which is -7 over 2. So our two solutions in our solution set are -7 over 2 and -1.